Okay, this is where we left off in our last video, where we found a formula for getting the sum of a geometric progression. Now, we want to see what we could use to find the sum to infinity of a geometric progression. Now remember, in order to find the sum to infinity, the progression would have to be convergent, which means r must be less than -1, right? Greater than -1 or less than 1. Now, you remember, if we have this as being the case, right? Let's say, for example, r is, say, 0.5, a half. A half raised to the power of 1 is half. Remember that a half raised to the power of 2 is a quarter. Half raised to the power of 3 is 1/8, and so on. As you go on and on, what you find is that the common ratio raised to the power of n will approach 0. Alright? As long as r is greater than -1 or less than 1. R could be, for example, 0.999, -0.999, or it could be positive 0.999, whatever it is. As long as it is greater than -1 or less than 1, that raised to a large power will be small. When you raise this to a power n, and n is increasing more and more, you will get a smaller and smaller answer, and it will approach 0. Now, sum to infinity equal, what will this approach? Alright, you'd have a times 1 minus r to the n over 1 minus r. But what happened to the r to the n? It will tend to 0. Alright? R to the n will get smaller and smaller and approach 0. So there now, when it is 0, what you would have is 1 minus 0. Right? As you get larger and larger. But the thing is, 1 minus 0 is 1. So I could write this as a times 1. But what is a times 1? A times 1 is just a. So it is a divided by 1 minus r. So the sum to infinity of a geometric progression is a divided by 1 minus r.